Welcome to a lesson on arc length and sector area. And this topic is closely related to some prior knowledge you have about circumference and area of a circle. We'll start with arc length. Now first you'll recall that an arc is a piece of a circle. And here we have an arc XY. And the measure of the arc is 60 degrees. Recall that the measure all the way around a circle is 360 degrees. We are asked to find the arc length, that is the distance in centimeters from point X to point Y along the circle. And then we're told to give our answer in terms of pi. That's called the arc length. Now before we look at arc length, let's pretend the question had asked us to find the circumference of a circle. You know from an earlier grade that the circumference of a circle can be found by multiplying 2 times pi times the radius. So we can substitute in the value of 15 centimeters for the radius. We can multiply the numbers 2 and 15 together, giving us the circumference all the way around the circle would be 30 pi centimeters. But we don't want, in this example, the distance all the way around the circle. We want the distance from X to Y. That is, we want the arc length. And so we can multiply what was the circumference times a ratio, where the ratio I'll be multiplying by is the measure of the arc in degrees over 360. And so I would ask you the question, 60 over 360, is that a fraction you can simplify? Sometimes you can simplify them nicely, and I can simplify that to 1/6. Notice I multiplied 2 times 15 to get 30, pi times 1/6. And now you can simplify 30 times 1/6 by doing 30 divided by 6, which is 5 pi centimeters. That is the distance in centimeters from point X to point Y along the circle is 5 pi centimeters. And so this helps us understand where the formula that some textbooks will give you for arc length, where this comes from. That to find the length of an arc, we simply multiply 2 pi r times the measure in degrees of the arc over 360 degrees. So we'll use this information in the next example. So the formula is given, and we're asked to find the length of an arc with a measure of 75 degrees in a circle with a radius of 4 feet. Notice no picture has been given. You could draw a picture, or you could visualize this, and I'm going to start by writing down the formula and substituting in the radius that's given and the measure in degrees of the arc that's given. And now I want to see if there's some convenient way that I can simplify this expression without going to a calculator. Is there something I can do? I'm noticing that 4 and 360 can both be divided by 4. And so 360 divided by 4 being 90. So I can rewrite my expression this way. Now I'm looking at 75 and 90, and I'm seeing that they both have a factor of 15. So when I divide both numbers by 15, I get 5 and I get 6. And then I'm going to divide 2 and 6 by the numbers 2. And I can get pi times 5 over 3. And that simplifies to 5/3 pi feet in this case. Now I would like to point out that while I happen to enjoy working with numbers and simplifying expressions, not everybody loves that. And especially if you're given access to a calculator on an assignment, then we would want you to be skilled using the technology. So what I did was I opened up to one of my favorite scientific calculators, which is the Desmos.com scientific calculator. And I typed in the expression that I had over here, but I left pi out of the expression. I typed in 2 times 4 times 75 over 360. When I hit equals, I got a decimal. But what's so nice is there's a button that just turns that into a fraction, and that's where my 5/3, and then I had to remember the pi came from. So that is my favorite scientific calculator, available online, desmos.com/scientific. So get used to using that too, and it would be great if you could get skilled at that technology. So 2 more examples on arc length before we move to sector area. In the first example, we have a circle, C. We need to find the arc length of arc PQ, that's a minor arc. We're told what the radius is, and we're told that the measure of that angle, the central angle, is 45 degrees. Therefore, the measure of the arc is also 45 degrees. So we want you to take a look at this example, put the video on pause, then come on back, and we'll see if we agree on our answer for the arc length of arc PQ. Start with the formula. And substitute in your values. Your radius is given as 5, and the measure of the arc is 45. And for me, I like to think about 45 and 360, and I can picture that there will be 8 of those, 8 45-degree sections going around the circle. So I know 45 over 360 simplifies to 1/8. I can see that 2 in the numerator and 8 in the denominator will, I can divide both numbers by 2. So I'm left with 5 pi over 4 units. My units for my answer will just simply be units for the arc length. Let's look at the next example. We're asked to find the length of arc MN. Information has been given related to the radius of the circle and the measure of the central angle. Again, put the video on pause, come on back, and let's see if we agree on what the arc length of arc MN should be. So we start with our formula, and we substitute in radius for 8 centimeters, and the measure of the arc is 135 degrees. And I will just tell you that this time I did type in this expression into desmos.com/scientific. I multiplied 2 times 8 times 135 and divided that by 360, and I got 6, and I remembered the pi. And our units for this one should be centimeters, so 6 pi centimeters. All right, we're going to move on to sector area. And you'll be pleased to know that this is closely related to something that you learned in an earlier grade, the area of a circle. And hopefully you remember the area formula is pi r squared. So looking at this example, it asks us for the area of the sector, that is the blue shaded region. But pretending that I wanted to find out the area of the whole circle, we would multiply pi times the radius of 12 inches squared, and we would get 144 pi square inches. That would be the area of the whole circle. But I want the area of part of the circle. So just like arc length, we're going to use a similar strategy for finding sector area. We start with what would be the area of a circle, and then I multiply by a ratio, the measure of the arc over 360. Notice I substituted in my values, and here 95 and 360 was not overly convenient for me, and I didn't feel like multiplying that by 12 squared, so I did use my scientific calculator, and I got 38 pi square inches. That's the area of this sector. So now our formula should make perfect sense to you. When we are asked to find the area of a sector, this would not be a hard formula to memorize because you've already got pi r squared in your memory, and you're just going to multiply by a ratio, namely m over 360. So let's apply this formula now to this example. Find the area of a sector with an arc measuring 174 degrees in a circle of radius 13 meters. So we start with our formula and we substitute in our values. That's our first step. Then I type in to desmos.com/scientific the 13 squared times 174 divided by 360, and I get what looks like kind of an awkward looking fraction, but nevertheless it's a fraction. So I'm going to leave that as my answer, but I won't forget pi, and I won't forget to include my units. So my answer is 4901 over 60 pi square meters. Notice area is always in square meters. All right, so your turn to try a couple. And this time I'm going to just go over both problems. Actually, let's do them one at a time. We'll start with the first example. And we have an area of a small sector there. You see the shaded region? It only has, the measure of that central angle is just 18 degrees. So that little arc is just 18 degrees. We want to find the area of the sector. And you're going to use your formula for area of a sector. Go ahead, substitute in your values, see if you can simplify, leave your answer in terms of pi. Put this video on pause and come back and check. So one nice thing was when we substituted in my radius of 10, that's a nice number to square in my head, and 18 over 360, that's also a nice fraction to simplify. Now why do I say that? Well, 36 over 360 would be 1/10, but this is 18 over 360, so this would be half of 1/10 or 1/20. And now 100 divides by 20 nicely, so my sector area is 5 pi. Now what will your units be? Square units, right? All right, now I want to move on to the next example. This example is trickier. Reason it's trickier is because I'm asked to find the area of the shaded region, that sector, which is actually more than half of the circle, right? It tells me that the obtuse angle is 170 degrees. Therefore, the other angle, which is really a reflex angle, it's more than 180 degrees, right? So when I use my formula for sector area, I can see that my radius is 7. That's not a problem. But the measure of my arc, be careful, is actually 190 degrees there. Go ahead and type that into a calculator, but this time use 3.14 for pi. And round your answer to the nearest hundredth. Let's see if we agree on the sector area of this circle. So rounding to the nearest hundredths, the area would be approximately equal. Now I have to use approximate because I substituted 3.14 for pi and I rounded to the nearest hundredth. So the area is approximately equal to 81.20 square units. So hopefully you feel like you could confidently do some practice problems involving arc length and area of a sector.